number 8, consider this series right here, the sum of n from 1 to infinity of n to the 5th divided by 2 to the n. Which of the following tests for convergence or divergence is appropriate for these series? So we're given 4 choices: the nth term divergence test, the ratio test, the root test, and the integral test. So we're going to pick one, and we're going to not guess a particular number, just determine whether this series converges or diverges. So we'll go in particular order. So first I want to look at the nth term divergence test. So as it turns out, the limit as n goes to infinity of n to the 5th divided by 2 to the n, this is equal to 0. So what does this mean? Consequence of this, the nth term divergence test tells us nothing. The nth term divergence test, if this limit were anything other than 0, or if this limit were to not exist, it would tell us instantly we can just go home, our series diverges. So it's good to check this one first, because if it did fail the nth term divergence test, we'd be done now. But unfortunately, we have to do more work. By the way, in case you're wondering about why is this limit true, why is this limit in fact equal to 0? If I convert everything over to x's, so I can use things like L'Hopital's rule. Right now we are in an infinity over infinity indeterminate form, so L'Hopital's rule does apply. So the derivative of the numerator would be 5x to the 4th. The derivative of the denominator would be natural log of 2 times 2 to the x. That's a good derivative to remember. And so we still have infinity over infinity. So we'd have 20x cubed, and this would spit out another factor of natural log of 2. And I don't want to do the rest of the steps, so this will take a bit more steps here, but you can see the exponent of the numerator is going down from x to the 5th to x to the 4th to x cubed, go to x squared to x to the 1 to x to the 0, while this is always going to be 2 to the x times increasing powers of natural log of 2. And so eventually you just end up with x to the 0, a constant over 2 to the x. That limit would clearly be 0 in that case as x goes to infinity. Okay, so the first thing that we've done, nth term divergence test, this is a bad choice. Okay, second thing to think about, the integral test. I'm going to do these out of order for a particular reason. The integral test, if we were to want to use it, couple of comments here. Number one, so this would be the integral that we would be comparing it to. We should also think about, does the integral test apply? So for the integral test to apply, the function, the integrand here, f of x, is x to the 5th divided by 2 to the x. This needs to be positive, continuous, and decreasing. So it's going to be positive, it's going to be continuous on the interval x is greater than or equal to 1. For positive and continuous works, for decreasing, it actually has behavior like this. So it's not decreasing for initial values of x, but once you get out to like x is equal to 10 or so, it is going to be decreasing. So, initial behavior, we could always chop this part of the integral off. We only care about what happens in the long run. We could patch up the integral test to make it apply. However, take a look at this integral. I don't have a clue how I would go about evaluating this integral. X to the 5th, that's fair enough, but divided by 2 to the x, this just looks flat out nasty. I have no idea how I would determine whether or not this integral converges or diverges. So integral test it would apply after patching things up, except for the fact that you just can't evaluate this integral. You can't determine whether or not this integral converges or diverges. So integral test, I'm going to cross that one off as well. 2 bad tests so far. 2 tests we don't want to use here either because it doesn't apply or it's too difficult to apply. Okay, so the third one I'm going to look at is the second one on the list. Once again, the series is the sum from n from 1 to infinity of n to the 5th divided by 2 to the n. Let's look at the ratio test. And the ratio test might be a good idea here because we do have a constant raised to the nth power. That usually plays kind of well with the ratio test. N to the 5th, that could get a little bit nasty, but that shouldn't sink our chances. Let's go ahead and try and see what happens. So this right here is our a sub n for the ratio test. So we're going to be computing the limit as n goes to infinity of absolute value of a sub n plus 1 divided by a sub n. Everything in sight is going to be positive, so I'll just drop the absolute value bars. We've got a sub n plus 1 is n plus 1 to the 5th divided by 2 to the n plus 1. All of that divided by n to the 5th divided by 2 to the n. Okay, so let's rearrange here. We have an n plus 1 to the 5th divided by n to the 5th times 2 to the n over 2 to the n plus 1. So that's going to cancel and just leave us with a factor of 1/2 in the denominator. And then we just have n plus 1 over n, all of this to the 5th power. Raising a function to the 5th power, that's a continuous function. So by limit laws, this is going to be, the limit is n go 1/2 times the limit n goes to infinity, n plus 1 over n to the 5th. This limit, it's very easy to see that that's 1, so we have 1/2. And so the ratio test, our row here, our row is less than 1, so our series converges. Converges absolutely everything is positive, so that's kind of meaningless. So converges. So the ratio test, the presence of this constant to the n, that turns out to be ratio test as a pretty good choice to use here. Now there's one final test here that I mentioned, the root test. So it says, which one of the following tests for convergence divergence is appropriate for this series? It gave you 4 choices, and it says, determine convergence or divergence using one of these tests. The ratio test, if you only have to pick one, the ratio test is probably the easiest one to use in this particular problem. However, I am going to show you right here that the root test also does apply. It's a little bit on the complicated side, but it will work out. So what does the root test say? We need to take the limit as n goes to infinity of the nth root of our individual terms. You can ignore the absolute value. Everything inside is positive. So we're going to take the individual terms of our series, raise it to the 1 over n power, and take the limit as n goes to infinity of that. So what do we end up with? Once again, this is a sub n. So a sub n, absolute value of that to 1 over n power. I can drop the absolute value bars. Again, everything in sight is positive. And so I can, break this up, numerator and denominator separately. So n to the 5th to the 1 over n power is n to the 5 over n power. And 2 to the n to the 1 over n power, the to the n and to the 1 over n, those multiply together to give you 1. So I just have this here. So this is the expression I need to take the limit of. So L is the limit as n goes to infinity of n to the 5 over n, all of that divided by 2. Okay, I can move this 2 outside, and in fact, I can move it to the other side to say 2 times L is the limit as n goes to infinity of n to the 5 over n. Okay, so how do we evaluate the limit as n goes to infinity of n to the 5 over n? So this looks nasty, and I think it is fair that this is going to be nasty to look at. However, as n goes to infinity, well, n is going to infinity, 5 to the n is going to 0. So we have like an infinity to the 0 indeterminate form. So whenever we have one of these exponential power indeterminate forms, we should think very much about taking natural log of both sides here, because we can move that natural log inside our limit and bring down the exponent. So what do we have? Natural log of 2L is equal to the limit as n goes to infinity of natural log of n to the 5 over n power, but I'm going to bring that exponent down. And a little bit of rearranging, limit as n goes to infinity of 5 natural log n over n. So now we are in an infinity over infinity indeterminate form. Life is great here. We can use L'Hopital. And so, what do we end up with? The limit as n goes to infinity of 5 times 1 over n divided by 1. And 5 divided by n as n is going to infinity, that's just going to be 0. Okay, so what do we conclude here? So let's come back over here. Natural log of 2L is equal to 0. So doing e to the both sides, e to the 0, that's 1. That's 2L. So L is equal to 1/2. And so by the root test, because L is less than 1, our series converges. So overall, I think that the ratio test is the best one here, but it should be worth noting that the root test does in fact apply here. I think this is a longer process to go through than the process we went through here to use the ratio test. We had to, do some Calc 1 throwback to evaluate this limit here. I'm realizing I probably, to make everything really, really airtight, I should have replaced the n's with x's to make it clear that we're allowed to use L'Hopital's rule in that sense, but I think you get the picture.